Hey everyone, welcome back to another video. And in today's video, so pen, my markers, I got a brand new question for you guys. And yeah, I just want to let you know I did cut my hair. Yeah, it looks good. Now I did this not just for fun, because for my health and stuff, there's a bacteria. So yeah, now I'm feeling better. It feels much more soft now. Yeah. So I just took a 3-day gap because of health and stuff. But now I'm fine. I'm recovering. I'm just kind of an over hygienic person, and I like a germophobic because I always like to stay healthy. I just sometimes I wash my hands twice and stuff. That kind of person I am. But I don't see that much of a problem because it's health. So yeah, it's currently 10:30 in the night, and we're gonna be solving this problem. Okay, let's get started. Okay, guys. So the reason I wanted to do this problem is you ever heard of a stop and jog? What is it called? Yeah. What is it called? When you're in between. Yeah, track your progress. Yeah. So those tracker progress questions in school books, that stuff in the middle of a chapter. That's what we're doing here exactly. And then we're doing complex numbers. We learn lots of things like the modulus, the argument, the algebra, the properties, the polar form, the proof, and the argand plane, the complex plane. We learned about the cubes of unity, how to solve equations with complex solutions. But that's not the end. We have more. I figured before going deep into De Moivre's theorem and how to solve cubic equations with complex roots, which is very it's not too easy, but we'll dive into that later. I want to do this question, okay? Now, before you do this question, pause the video and try to solve it yourself. Okay? It says if we have a function f of x is equal to a times x to the n power plus b into x into the n minus 1 power plus cx into the n minus 2 power plus all the way plus dot up to m. So it's this function is not n, it's a general function because this is an exponential function. Because in this case, the variable we have right here, this is a variable. Same with n minus 1 and minus 2. So these are called exponential functions. This is an exponential expression. Yeah. And we're given that n is an integer, specifically a positive one, because if it's negative, that's a whole different story. But for now, we're dealing with positive integers. Okay? And I just want to say that this question, it's not from any source. I kind of made it myself. I decided to make a question. I just randomly came up ahead, I swear. I did not copy that, so you could check. It's not any test. It's not any source. It's just, I didn't even use ChatGPT to make this. It's my own question with my own knowledge. So, pause the video, try to solve this, and once you're done, just let me know. Done? Okay. Let's solve this. So let's see. Now before going to the answer, I don't know specifically about functions. Look, when we have a function, let's talk a little bit about functions. Okay? Now I don't know if I haven't taught functions deeply, but I'm assuming you guys know that. If you don't, it's okay. It's basically in the form f of x or g of x or h of x. X is just a variable. It could be a. This could be it could be e, f, g. Basically, in a function, these are called functions. Okay? Yeah. Basically, f of x. And also f of x, this does not mean f times x. The reason is because in this case, suppose we have f of x. In f of x, see, look, f of x is the function. This is the input. X is the input. Okay? And suppose we get something like 5. This is the output. So it means, now this is not an equation to solve. This is just a normal equation. It's just a normal equation. It's just a statement. Where like, for any input x, 5 will be the output. So like if I say, if you just like, that's what it means basically. Like for what value of x, for every input of x you get 5. This is what it means. Now suppose we have variable. Suppose we have something like 2x. Then suppose we have to find f of 5. So what we have to do is we have to plug in 5. So this would be equal to so x is equal to 5. 2 into 5. So it'll be 10. So this function right here evaluates to 10 when we plug in x equal to 5. Okay? These are basically what functions are basically. So you can understand them. And suppose we have something like, suppose we want to find, suppose x is equal to 2x. So what do we have to do? We basically have to plug in 2x. So this means f of 2x would be 2 into 2x. It would be 4x. Okay? Now also, no, let me just say something. No, one more thing. If f of x is equal to k, where k is a constant, this is not an equation. No solution. A general statement. So basically, I know when I said f of x is equal to 5, this means that we can put any value of x which is 5. But that's not true actually. There's no value of x you can put to make it 5. It doesn't make sense. Like if you say f of 1 is 5, f of 2 is 5, you're just saying that one function is equal to a variable. Like in this case, we let a polynomial equal to a function. Okay? Yeah. But the difference is this is a polynomial, so we can plug in values. But this is a constant. We can't plug in the values. This is just a statement, like saying f of x is equal to 5. It's like you can't solve for x. You can't solve for x in that, okay? So I hope you understood functions. These are basically what functions are. And you can use f of x, g of x, h of x, whatever you like. And the most common variable uses x. Okay, so we'll dive into functions later. I just want to give you some basic introduction on functions. Because, functions, they're like increasing, decreasing, odd, even functions, but we're going to dive into it later. Alright? So, for now, let's dive into the solution. Okay, look. Now, it says, let's read the question. It says, if a function is equal to this expression, where a, b, c, up to m, so a, b, c, all the way up to m, like d, e, f, like, yeah. Also, this is not meant to go from a, b, c, d, e, f, g, h, j. It's not meant to go in alphabetical order. These are just variables. These are just places like coefficients. Okay, so all values like from the ax to the n plus bx to the n minus 1 plus x to the n minus 2, going all the way down to a constant. Okay, we don't know what n is yet. We're just given a general polynomial. This is an exponential polynomial. So we're given that x is a variable, okay, and we have n is a positive integer where n is greater than 1. This is very important. Don't miss this out. N is greater than 1. Don't miss it out, okay? And now the question is, explain and justify if f of x can have an odd number of non-real complex zeros. Interesting. Basically, before I say zeros of polynomial function, when we say zeros, it just means what value what value that variable of the expression gives when it is equal to 0. So that's what 0 means. Like, this is the standard form of a linear, quadratic, cubic equation, and so on, quartic. Like ax plus b is equal to 0, ax squared plus bx plus c is equal to 0, ax cubed plus bx squared plus cx plus d is equal to 0. This is the zeros. This is the standard writing, okay? So you should understand the math language, okay? Understanding math language is very important. And that's why we say it's a language also. Kinda, you know. So look, now there's something. So you're like, man, how are we going to determine if this long equation, which has like so much variables, how can we determine if it has an odd number of complex roots or not? Like, man, I'm just so confused. But no, don't think like this. Here, I'm here. Let's break it down first. Okay, so we're given that f of x is equal to ax to the n plus bx to the n minus 1 plus cx to the n minus 2, and then okay, we add all these exponential monomials, okay, up to when we reach a constant. It's like when we have a quadratic polynomial in the form like ax squared. Like, these are just examples. These are not. This is just a general form. These are examples like ax squared plus bx plus c, ax cubed plus bx squared plus cx plus d. This is a quadratic. Yeah. This is quadratic, right? This is quadratic. This is cubic. And so on up to quartic. So for quartics, it will be x to the 4 plus bx cubed plus cx squared plus dx plus e equals 0. Oh, yeah, that's what it is basically. So these are the polynomials, okay? Okay? And for the zeros of it, we just let it equal to 0. This is standard form, right? That's the same thing here. It's asking for the zeros of this. But this could be anything. It could be linear, it could be quadratic. Oh wait, no. Look. N is greater than 1. This means this is not linear. Cannot be linear. Cannot be linear. N is greater than 1. This is because n is greater than 1. So this is why this cannot, because see, because if n is greater than 1, it could be ax cubed plus bx to the first power plus cx to the 0th power. Wait, what? Anyway. So ax squared plus bx plus c, or if it's 3, it'll be cubic, 4 will be quartic. You know, see, look, this is a pattern. If n equals 2, it's quadratic. I'm just saying. If n is equal to 3, cubic. N is equal to 4, this will be quartic, and so on. Like, you can plug it in. If like it be x cubed plus bx squared plus cx plus, I mean, there's some variables here, we don't know that, but it's just d, and so on. Okay, so now at least we come up with the conclusion that this cannot be linear. Okay, understood? Okay, now we have, can this have an odd number of non-real complex zeros? Interesting. We have to use theorems. Now look here. Non-real. Now, have you heard, do you guys remember the complex conjugate root theorem? Yes. Let's rediscover one more time. Complex. So we're going to figure out the complex conjugate root theorem. Now this is where I think the solution will actually start. So complex conjugate let's see. So let's see what it states. It states that here. Look. If an equation has a non-real root a plus bi, a minus bi is automatically another root. So basically what this means is here, higher than linear holds for quadratics and above. So basically it says if we have an equation which has a non-real root, a plus b are non-real. Okay, not real number, because we know real numbers are a subset of complex numbers. So we can write every real number as a complex number with the magic part 0i. But in this case it's non-real. And this is we say for quadratics because linear equations only have one root. Okay? They only have one root, so this doesn't hold, okay? So basically, like in quadratic equations, if you solve an equation, you notice the negative b plus or minus the square root of b squared minus 4ac upon 2a. The plus or minus is the conjugate. We can break it down to negative b plus the square root of b squared minus 4ac upon 2a, or and negative b minus the square root of b squared minus 4ac upon 2a. These are conjugates, and we can break it down. And we can just break it down. We can put the denominators like negative b upon 2 plus the square root of plus or minus the square root of b squared minus 4ac upon 2. And that's to break it down in the form. But for quadratics, for a will be the solution would be if there's a non-real complex root, okay? If it has non-real complex roots for a quadratic equation, I'm saying for example, then it would be something like negative v upon 2 plus or minus the square root of b squared minus 4ac upon 2, like that. Okay? Yeah. So we can just break the plus or minus is the conjugate. These are conjugates, remember? Yeah. Okay? So these are known as conjugates as well. So that's what we use. Now we solved quadratic equations before. You can solve one and check it out. This is the theorem we're using basically. Okay? But also, as I mentioned, A, B are real numbers. Yeah. A, B are real numbers. This is not real. Real. I is the imaginary unit. Yeah, you should know that. It should be obvious by now what A and B are, and I. Okay? So using this theorem, we can also determine something. We can determine, yeah. So where do I write this? Yeah. Now just make space. Okay. So I have to note that down. Just note it down if you haven't noted it down. Okay. So observation. So from the theorem that we observed, where the roots of if an equation above quadratics and above has non-complex roots, they come in conjugates. So we can say that, equations with such solutions, I'll start with such solutions will always come in even non-real complex roots. And even non-complex roots because complex roots because a pair of complex roots always come in two. This is very important. Okay? Always. Because the thing is, complex conjugate, with the complex conjugate root theorem, we know that the roots will come in like a plus bi into a minus bi. So the roots, a pair of complex roots will always come in two. Because first root will be a plus bi, second root a minus bi. Okay? And yes, the number can be imaginary as well. Okay? It can be imaginary or complex, but can't be real. Okay? So this is what it says. Because, like for example, if we have like roots, if these are the roots, like if this is a pair, suppose we have another pair. Suppose we have this is pair 1. Okay? Let me just erase this. Now I'm going to explain the reasoning behind this. Okay? Look, the thing is basically, suppose I'm going to call this pair 1, okay? Pair 1. So it's not possible for an equation to have a pair more than 3 complex roots. It's not possible. This is the first pair. These are conjugates of each other. Okay? So like, if we had a second pair, the pair cannot be odd. Because according to this theorem, this beautiful theorem that we have right here, my pen is not working for some damn reason. I don't know why. And this works, you can test it out. They come in pair always. You can solve cubics, quadratics, quartics. It's kind of hard, but it works. In pair 2, the third root would be, let's call it c plus di, and the fourth root would be c minus di. So they come in conjugates basically, and this goes so on. Okay, this is how it goes. Like you can't say pair 3 will have only 1 complex root. No, the third pair will have 2. That's how it works. Yeah. So basically, no, this is basically how it works. You know that? Yeah. So for pair 3, it'll be something like x plus yi into x minus yi. So for pair 3, it'll be the 5th root will be x plus yi, 6th root x minus yi, and so on for many pairs. And the number of roots, yeah. So this is the theorem that we're using. There's only one theorem, I guess, because we're asking if it can have an odd number. So yeah, I think we should put the answer now. The answer would be no. Oh god, it's a big space. Okay. So let's put the answer right here. The answer is no. Okay? And the reasons why I explained in the video. Let me put theorems used. Theorems used. Complex. Conjugate. Complex conjugate root theorem. I think this is the main term we've used in the video so far. And this is the main one. And this is a theorem called fundamental theorem of algebra. Yeah, like for example, like if you have a polynomial, like if z to the n is equal to a constant k, then the equation would have an n number of solutions. But this is not related to this. Okay? But I think yeah. But I think we should add one more theorem. Let's see. Fundamental theorem algebra. Yes. So look. So let me explain on the side. Basically, the fundamental theorem of algebra is like something like, suppose we have like something like this. If z is a variable, okay? If z is a variable, there's a variable, n is a positive integer, okay? And k is a constant. So z to the k, or z to the n equals k will always have an n number of solutions. Right? Look, basically, look, when we solve linear equations, the power is 1. So we get one solution. Quadratics 2, cubics 3, quadratics 4. It tries out the power. Okay? And I think it's important because, like, in the equation, see, the thing is, we have a, like, if you can have an odd number, this is a relative number. I mean, like, if the power is even, obviously there will be an even number of roots. If it's odd, we'll have an odd number of roots because it's the n. But the question is not directly asking that. It's asking like if you can have an odd number of non-real complex roots. Zeros. Yeah, if it's equal to 0. Okay? So it's not even possible. Like if it did have a non-real complex root, it would always come in a complex. It will always come in conjugate pairs. Okay? Because the roots would always come in conjugate pairs. Okay? Because as I explained in the complex conjugate root theorem. Okay? Alright? So this is pretty it for the video. Okay? Yeah, because like we don't know if this equation will have real or non-real roots. But this theorem, I guess we can add this theorem. It works, kind of. You know, it depends on the question. If a teacher asks for 1 or 2, if 1, this is definitely recommended. If 2, add this as well. You know. So yeah, that's basically like. Let's see. If n was 3, this would be cubic. We would have like what, 3 roots. Yeah, it's an odd number of roots. But we don't know if the roots are real or non-real. And same if it's 2, okay, the roots are even. But how do we know if the roots are non-real or real? Okay, it's even, but we have to know that. But so this, I guess this theorem helps to build on in this theorem. Okay? So I guess this is like basically what that is. Okay? Alright? And yeah. And if n was equal to 1, then yeah, I mean, it is possible to have, for a linear equation with a non-linear root, to have a single complex root, because 1 is an odd number. Yeah, but because linear equations are the highest power is 1, that's the why. So let's write the solution here. The solution is no. Absolutely not. Okay, I think I should make this better. Theorems used. I hope you enjoyed the video. Like and subscribe for more. You know. Okay. So guys, if you have any doubts, let me know. I'm always here. Okay. And never stop learning. You know, math's fun. You're gonna enjoy it. And yes, this topic is not over, but I hope you enjoyed this question, the concepts for the basics. If you have any questions on the basics of the, like about functions or equations and polynomials, or the solution, you can let me know. I'll make a separate video on that, okay, for you guys, because I really care for you guys. You know, I know this channel is made for fun, but you know, I also wanted that, you know, you guys learn a lot, because this is very interesting, you know. And I'm so happy I grabbed this question. And yes, it doesn't matter if n is even or odd. Okay, it will always come in conjugate pairs. You could solve a cubic equation or any quadratic equation. It works. We've solved like some rational equations on this channel, the community post as well. You can see that they always come in conjugate pairs. Okay, like in the cube roots of unity concept. In the cube roots of unity concept, did you see that? Okay, we had one real root, but that's a real root. We give the side. We had two complex conjugate roots. We had a pair of complex conjugates. Yeah, it was something like what was it? -1/2 plus or minus the whole square root of 3/2 into I. Yeah, that's the cool thing. Yeah. So basically, in the complex conjugate roots theorem, the roots will always come in conjugate pairs. Okay. So yeah, that's all. It's right here. Yeah, roots will always come in conjugate pairs. Okay? Just note that down. Yeah? That? Yeah, okay, good. So I hope you enjoyed this video. You know, leave a like. You know, I love making videos for you guys. And yeah. If you want, you can note that the answer is here. This is the answer. And if you want the explanation, you're gonna have to watch the full video. Because I also speak, you know, because writing it down is kind of tiring as well. But you know, it's fine. Okay? So if you have any doubts or if you want to say something, you want to compliment me, go ahead. Comment section's free. It's for you guys. Okay? I keep fixing those. Okay. You know, I think I'm going to end it here. This is a summary of all the things. I hope you enjoyed the video. You know. Ooh. Okay? So, yeah guys, I hope you enjoyed the video. Okay? So yeah guys, until then, see you in the next video. We'll come back with more content, okay? So yeah. Peace out.